Okay, so today is section 3. Today we're going to be proving triangles similar by AA. And that AA represents angle, angle. So it's a shortcut to prove triangles similar. And again, just like the shortcuts for congruence, like the side, 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 angle, side, now we're going to have shortcuts for proving triangles similar. And here is our AA similarity postulate. And it states that if two angles of one triangle are congruent to two angles of a second triangle, then the two triangles are similar. So I need to somehow, some way, find that I have two angle pairs that are congruent. So A and D are congruent, and B and E, because they have the congruency marks. And again, your similarity statement, the order of the letters is important. So notice how A is the first letter, and it matches with D, B matches with E, and C matches with F. I know by my third angles theorem that angles C and F would also be congruent. Now this AA similarity postulate, this only works for triangles. Only for triangles. Okay, let's try to apply these. Now, what gets a little difficult is some of the triangles are going to be nested within the other triangle. So if it's easier for you to pull them apart to see them separately, you can do that. So let's try example 1. All right, so here we've got 4 examples. They want us to decide yes or no if these triangles are similar. So the two triangles it's referring to in this question are this top one and then the whole thing. Now notice it's got parallel lines here. What if I draw in a transversal? Anybody see any angle pairs that might be congruent and what they're called? Anybody recall this one and this one, what they're called when I have corresponding angles? So I could show that I've got the small red one and then the larger blue one, and I can show that this angle and this angle are congruent. Now I could draw a transversal on the other side also, and also show that this side also has corresponding angles. So if you were writing this in a proof, you would have said, and they would have letters on here, and you would have said that this angle is congruent to this because of corresponding angles. We also could have said the tippy top here. See this angle up here? This is the same in both triangles. So if you were writing this in a proof, you would have said that was reflexive. However, I didn't need to show all 3. My goal here is to use the AA and just show 2 angle pairs, not all 3. So yes, these are similar. And the way that I found that they're similar is by my angle similarity postulate. For B, are these similar? Yes, this one was obvious. They already had the angles marked for us, so we would say yes. And again, the same reason by the AA similarity postulate. Over here, the 2 triangles I'm referring to are this one on this side and this one on this side. I've already got one angle marked up here. Can I pull in another pair of angles that are congruent? Where? Nope, I can't assume that. Nope, I can't. Nope. Yes. Okay, so we could do that, and then we could do CPCTC. Okay, that's one way. You could have said this reflexive. Now, We could also say this is an isosceles triangle, the whole big thing. You guys remember the base angles theorem? So down here, these base angles are also congruent. So we could have gone about this several different ways, okay? But yes, these are similar, and we could establish AA, or we could establish that the triangles were congruent, so therefore they're similar. This one, I'm talking about this one here, and the whole thing. Now I already got one angle. Where's my other one?
Angle that they both share.
Beautiful. This one right here. It's the same angle that's in the red one that's in the blue one. And if you were writing that in a proof, it would be reflexive. So yes, these are also similar, again by AA.
I don't get why they're similar. What do you mean, like the angle that you have?
Okay, so let me erase some of this. All right, my goal here right now is I've only learned one shortcut. And prior to this, yesterday, the way to prove that two figures were similar is I had to show all angles were congruent and all sides were proportional. Now, right now, I don't have any side lengths. All I have are two figures, or one figure that the triangles are connected, and I have only one angle marked as congruent. So I've got this triangle here. Let me do it like this. And then I'm talking about the blue one. With me? So this angle that's right here for the red one is also the same angle that's in the blue one.
Oh,
Okay, so because that angle is the same in both triangles, then it's congruent by reflexive, and then I had this other one that was marked from the beginning. So because I have two angles that are congruent, yes, they are similar by the angle-angle similarity postulate. Let's go to the next one. All right, so now, in order to find the value of x, I need to first decide, are these triangles similar? So again, the triangles I'm referring to is this little one here, and then the entire triangle. And I'm going to pull them apart, just maybe to make it easier to see. So here's my large red one. This side length right here is 5 plus x. Over here, this side of the large one is 3 plus 1, which is 4. Then I've got the small blue one, and it has a side here of 3 and a side here of 5. Everybody with me? Now, let's go ahead. We've got parallel line markings on here. So let's see if we can find two angles. So here, I've got parallel lines. So if I draw a transversal, I could establish that this angle is congruent to this, corresponding. I could also draw another transversal over here and show these are congruent. I could even show my reflexive and show the top one. So I can show that all three angles are congruent. So now that I've established that they are similar, now I can find the side length by setting up a proportion.
Wait, how did you find the blue lines
The blue one, well, let me erase this one. Those are also, I have parallel lines here, and then I have this transversal. So they're corresponding. This one up at the top here is reflexive. It's the same angle for the little red one as it is for the big blue one. So it's congruent to itself. All right, so now let's set up a proportion to find the value of x. So for this one, I'm going to match my sides. So I can match the 4 and the 3. And then the 5 plus x over the 5. I'm going to cross multiply and divide. So 3 times 5 plus x, and then 4 times 5. Distribute. Move the 15. Divide by 3. And x equals 1 2/3. Don't make it a repeating decimal. Just leave it a mixed number. Let's try the next example. They want us to write a similarity statement. They also want us to find the value of y and of x and show all the proportional sides. So again, let's pull these apart. So I have a small little red triangle right here. So let me pull that out. DEB, 3, 4, and y. Then I have the large blue one here. And this will be CAB. This side length here is x plus 3. This one will be 8. And this one's 3 plus 4. And this side is 7. So now, again, in order to prove them similar, I need to come up with 2 angles that are congruent. Again, I've got parallel lines marked here. So if I draw in a transversal, I have this angle congruent to this. I could draw another transversal over here, do the same thing, or again, do the reflexive and say B is congruent to B. So now that I've established that C and D are congruent, and B, or even A and E, because they're also corresponding, now I can write my similarity statement. So you can see that angle A matches with angle E, B is B, and then C matches with D. And that's your similarity statement. The order of the letters is important. So now, let's find the value of y. We need to set up a proportion. So notice y is right here. I also need to find a complete ratio. My complete ratio is going to be using the 7 and the 4. So if I do 7 over 4, and then again, remember you wanted 8 and y. Now, if you chose to put 4 over 7, then the y would be in the top of the fraction. Let's cross multiply. 7 times y, 4 times 8, divide by 7. 7 will go into 32 4 times. 4 times 7, 28. 4 left over. So 4 and 4/7. Now they've already started out our proportionality statement. So let's figure out the other 2 sides and what they match with. So they've already shown us that BE, this one, this side matches with BA. So then I can come over here and say BC is going to match with DB. And then I can come over here and say AC and ED. Now, keep in mind that all of the numerator comes from the smaller red triangle. All the denominator sides are coming from the large blue triangle. The order doesn't matter. If you put DE or CA, the order of the letters doesn't matter. If you want to just go consistent Like if you wanted to go from the 1 mark to the 2 mark and do CB to DB, you can do that. So like if you wanted to make sure everything lined up, you could do that. Yes?
Instead of putting it as a proper fraction, can you put it as a decimal?
Does it terminate? I don't know if that terminates. I would leave it a mixed number. Let's see if I divide that. 4 divided by 7. Look at the crazy decimal it gives you. I would leave it a mixed number. Don't leave it improper. Anytime you're looking for a side length, do not leave it improper. Now, if it'll turn into a decimal that terminates, you can do that. But if it's repeating, leave it a mixed number. Now let's find the value of x. And we can see that x is over here, and it matches with the 3. So we can do x over 3, or x plus 3 over 3, and then use the same scale factor. 7 over 4. So 4 times x plus 3, and then 3 times 7, 4x plus 12. Move the 12. 4x equals 9. Divide by 4. And x equals 2 1/4. Nice and easy proof. Okay, so again, we're back to 2-column proofs. Statements, reasons. Number 1, I'm going to state my given. AC parallel to BD. And that was given. Now, what's nice is we've only learned one shortcut. So my goal here is to find 2 angle pairs that are congruent. Anybody see an angle that's congruent to the other angle? So the vertical angles, yes.
Yeah, DOB and AOC.
Good. So angle AOC is congruent to angle BOD, not triangle. Let me fix that. And those are vertical angles theorem. Now notice I also have parallel lines here. So I just mark these. If I draw a transversal here, I now can say that angle C is congruent to angle D. Anybody know what kind of angles those are? Beautiful. So alternate interior angles theorem. And now my last statement is what I was trying to prove. That AOC is similar, not congruent this time, to triangle BOD, and that's the AA similarity postulate. You can just put AA. You don't need to put similarity postulate. Okay, so you do have homework on this lesson. It is in Canvas. It's due tomorrow.